going to do something on practical builders estimating. So we're going to see working on unit rate given items of work. So that's in practical builders estimate. So I have a question here which goes this way. Work out the unit rate of the following item of work with the following information. So I have a concrete here in trench foundation exceeding 300 millimeters thick per cubic meter using 10/7 mixer continuously. So we're going to use using 10/7 mixer continuously. Assume the mix is in this ratio, that's 1 to 3 to 6. Then we also have the density of cement here being 1420 kilogram per meter cube. We also have the density of sand being 1600 kilogram per meter cube. Then the density of coarse aggregate, C aggregate is coarse aggregate being 1400 kilogram per meter cube. We also have cement including unloading at cash. So for cement now, the cost of cement including unloading is the same as 18,100 Kenya shillings per ton. And then for the fine aggregates here, we have the cost being 1,000 per ton. And then the value of the cost of coarse aggregate at 1,000 per ton also. So the shrinkage and consolidation and wastage add 50%. So for the materials here, which is the cement, sand, and coarse aggregates, we should add an allowance of 50%. That's for the wastage. We also given this information for labor gain. Labor gain here required for such a machine is as follows. So we have one driver, stroke filler, one filler. We also have 3 wheelers and 2 spreaders. So we have a total number of 7 workers here, 7 workers. So rate per hour by laborer. So we given to be 50 shillings. So Kenya shillings, we have it be 50. That's the cost per hour per laborer. So we also have 10/7 concrete mixer. Cost of the mixer itself, we have it to be 250,000 Kenya shillings. We also have the depreciation on average life condition of 8,000 hours. So depreciation this length for hours, so we have 8,000 hours. We also have interest, taxes, and insurance being 10%. Repairs and maintenance given to be 20%. Fuel per 8-hour day, so per 8-hour day, so meaning the 10/7 concrete mixer is working for an average of 8 hours in a day. So it's consuming 7 liters fuel per day, 8-hour day. And then the cost of diesel per liter is given to be shillings 90. So we are also provided with this information for lubricating oil required per week is 404 liters. We also have the cost of lubricating oil per liter being 350 Kenya shillings. Also the output of the mixer given to be 2.4 meter cube per hour. So the concrete given the mix being 1 to 3 to 6. So this one stands for 1 meter cube of cement. We also have 3 meter cube of sand, and then 6 meter cube of coarse aggregate. So this is the mix of the concrete. The final mix is in this ratio. So the density of cement given to be 1420, sand 1600. Also for coarse aggregate 1400, 1800 for cement, cost of cement per ton. Then for coarse aggregate per ton is 1000 Kenya shillings. So for 1 meter cube of cement given to be 1420 kilonewtons per meter cube at shillings 18,100 per ton. So we're going to equate if 1 meter cube is the same as 1420 kilogram per meter cube provided here. That's cement cost per ton. And in this ratio, we had the value of the volume of cement used here is 1 meter cube. So this 1 meter cube, so if 1 meter cube of cement having this density cost is, what about 1 meter cube? So meaning it's going to be the same. So, but first, here we had 1420 kilogram of cement in 1 meter cube. Okay, so this is the mass in 1 meter cube of cement. So that's 1420. So we're going to convert this one to be in tons because the price here is given per ton. So converting this to tons, that's 1420 kilogram into tons will be 1.420. 1.420. So if we are given that the price per ton is 18,100, what about 1.42 kilogram? 1.42 tons will be how much? So it will be 1.42 tons. You divide by 1 ton, you multiply by 18,100. So you're going to get this 25,702 Kenya shillings. That's the cost of the cement. So we move the next, which is the volume of fine aggregates in the ratio. We're given it to be 3 meters cube. 3 meters cube, but initially we're given that the density of fine aggregate is 1600 kilogram per meter cube. So meaning we have 1600 kilogram in 1 meter cube. So we're going to find the value of the mass, the aggregates, fine aggregates in 3 meters cube of fine aggregates. So we're going to convert first this one to be newtons. So divide by 1000. So 1600 divided by 1000 to be in tons. So it will be 1.6 tons. So we have 1.6 tons here in this density. So if we are given that 1000 per ton and we have 1.6 tons, 1.6 tons of fine aggregates. So in this volume, the mass will be 3 you divide by 1 meter cube. You multiply by 1.6 tons. So you're going to get the value of the mass, total mass in 3 meter cube being 4.8 tons. So if the cost per ton is 1000 Kenya shillings, so you're going to multiply 4.8 tons by 1000, you're going to get the value of the cost of fine aggregates being 4800. And then move the next, the cost aggregates. So in the ratio, where the volume of the fine aggregates, not really the coarse aggregates, the volume in the ratio being 6 meter cube. So this 6 stands for 6 meter cubes, and that's the volume in the mix. So 6 meter cube of coarse aggregates at 1400 kilogram per meter. That's the density of coarse aggregates. So this means that we have 1400 kilogram in 1 meter cube of coarse aggregates. So not about 6 meter cube will be which mass. So 6 meter cube you divide by 1 meter cube, you multiply by 1400. So you're going to get the value being, but you're going to multiply by 1000 because the cost of one ton of coarse aggregate is 1000. So we're going to say 6 meter cube you divide by 1 meter cube, you multiply by 1400, which is the mass in every meter cube of coarse aggregate. Then you divide by 1000 to be in tons because you're going to get the value in kilograms. So dividing by 1000, so that 1000 will cancel with this. So you're going to get the value of the price of course aggregates being 8400. So the total cost now of the mix will be given by 25,702. You add the value of the price of fine aggregate, which is 4,800. Then finally, you add the value of the price of what aggregate. So you're going to get the value of the cost of the material will be 38,902. So this price now will be carried forward. So you carry this forward because you're going to add the allowance of 50%, which is the wastage. So 50% of the total cost of the material will be 50 over 100, you multiply by 38,902. So you're going to get a value of wastage being 19,451. So adding this now to 38,902, the total material cost will be 5,853 Kenya shillings. But in this mix, we have a total volume of 1. You add 3 meter cube of 1 meter cube of cement. You add 3 meters cube of the fine aggregates. Then you add 6 meter cube of coarse aggregate. So this is in the mix. So we have a total volume of 10 meter cube. So we're going to find the value of aggregate in 1 meter cube. So if 10 meter cube will represent 10 meter cube will represent is 58,353. So dividing by parts of mix, which is 10. So you divide by 10, you'll get the value of 1 meter cube of the concrete mix being 5,835 Kenya shillings. So cost of material in 1 meter cube of concrete is 5,835.30. That's in Kenya shillings. Next. So next going to calculate the operation cost including the owning costs. So first we're going to start with this owning costs. So we're given that the cost of the plant here, the cost of the plant is given to be the 10/7 concrete mixer. The cost of the mixer is given to be 250,000, and given depreciation on average life condition of 8,000 hours. So we're going to find the depreciation rate per hour. So you're going to divide, you say 250,000, you divide by 8,000 hours. So depreciation per hour will be, so the depreciation per hour will be 31.25 Kenya shillings. So every hour this machine or this mixer is depreciating at this rate, this price, that 1.25. We also have interest, tax, insurance, and we also have repairs and maintenance. So the value of the interest, tax, and insurance given it to be 10%. So since we already have the depreciation per hour, also going to add the interest taxes percentage. So it is, so interest and taxes given to be 10%, repairs also 20% of this. That's per hour. So 10% you're going to multiply by that one point that one point that one point that 1.25. So 10 or 100 by that 1.25, you're going to get this value, that's 3.13. Then for repairs and maintenance, 20%, that's per hour, is equal to 20 divided by 100 by that one multiplied by that 1.25. So you will get a value here which is 6.25. So for hourly owning costs, because everything here is in per hour, so you're going to add this depreciation per hour, that 1.25. The same case, the interest and tax insurance per hour, that's 3.13. Okay. And then repairs and maintenance, 6.25 per hour. So you're going to add everything here for you to get the hourly owning cost, which is 40.63. So next, we also have the operating costs. Operating costs. So operating costs here, operating costs are given here. The operating costs. The operating costs here are given the fuel per 8-hour day. So per 8-hour day, the fuel being 7 liters. Then the cost of diesel per liter is 90. That's per 8-hour day. So the total cost per 8-hour day is 90. So it's 90 multiplied by 7. So you're going to get the price now. Per 8-hour day it's using 7 liters, so you multiply by the price per liter. So 7 by 90. We also have the oil required per week. So the oil, the value, the price of oil is given per week, which is 4 liters. So it's 4 liters now. And the cost of oil per liter is 350. So 350 multiplied by 4. So you're going to divide by 5, which is, we assume that the machine is working for 5 days, that's 5 working days. So it's 350 by 4 divided by 5 days for you to get the price per day. So here we already have the fuel per 8-hour day is 7 liters. So this per 8 hour. So per 8 hour is 630. Then this one by 8 hour is 280. That's 4 by 350 divided by 5 hour working days. So you'll have 910. So for fuel and oil per hour. So fuel and oil per hour, because it's given that's 8-hour day. What about 1 hour? So 1 you divide by 8, you multiply by 910.00. So you can get the fuel and oil per hour is 113.75 Kenya shillings. So hourly owning and operating costs will be, you're going to add this value here, that's operating costs per hour, and then you add the owning cost, which is 40.63. So hourly owning and operation costs will be 40.63. You add this, so the value will be 154.38. Next, so we have the cost to produce 2.4 meter cube. It's the same as 350. So since we had the number of workers here being 7 workers, we had labor king here, we had 7 workers. That's 1 driver, 1 filler, 3 wheelers, and 2 spreaders. So this one would be 7 workers. So the rate in which these workers are paid is given here, being the rate per hour per labor is 50. So if you multiply 7 by 50, you're going to get its value here. is 350. The cost being paid to the laborers per hour. So if this 350 is the amount being paid to the workers per hour, what will be the volume now in which these workers will be paid for this price? So we're going to divide this price 5,835 divided by 350. So if you divide this price by 350, this is the rate in which the laborers are paid per hour, you're going to get this. So they are mixing 2.4 meter cube in every 1 hour. Okay. So now therefore the cost of 1 meter cube. So if 2.4 meter cube will be this price here. What about 1 meter cube? How much will the laborers be paid for doing a work of concrete mix for 1 meter cube? So it will be 350 divided by 2.4. So they'll be paid 145.83 Kenya shillings for doing 1 meter cube. So hourly costs of 10x7 mixer as previously worked out to produce 2.4 meter cube concrete was the 154.3. So here we had the hourly owning and operating cost being you add the owning cost, you add the operating cost. So we had being 154.38. So here, so this, because now the concrete mixer we were given initially that this concrete mixer is working at this rate. Yeah, here, here. Output of the mixer is 2.4 meter cube per hour. So this is the output. So if it's doing this kind of work in 1 hour, which is 2.4 meter cube per hour, what about 1 meter cube? So 1 meter cube will be doing after. Okay. So for 1 meter cube, if 2.4 meter cube is the same as 104.38 Kenya shilling, what about working for 1 meter cube of concrete? So 1 meter you divide by 2.4, you multiply by 1.438, going to get this value, which is 64.33 Kenya shillings. So the question was here. The question here was work out the unit rate for the following item of work with the following information. So this was the information, and we already did the cost of 1 meter cube of concrete, the cost of paying each worker for doing 1 meter cube. The same case, the concrete mixer being paid the price we got for working for 1 meter cube. So the unit rate per meter cube now will be, so we're going to add, which is 5,835.30 Kenya shillings. That's the cost of 1 meter cube of concrete. Same case to this is 145.83, which is the cost to produce 1 meter cube. That's by the labor again. So they are being paid 145.83 per meter cube. So, and the machine also, the concrete mixer being paid 64.33. So it's more economical as compared to the labor gain. So now the total cost now, the unit rate per meter cube, you're going to add everything here. This is 5,835.30. You add the cost being paid to each the labor gain for doing 1 meter cube of concrete, and finally you're going to add this one 64.33, which is the price being paid the concrete mixer. So the unit rate per hour will be 6,045.46 Kenya shillings. So this is the end of the tutorial. Thank you for watching. Make sure you subscribe.